In a previous video, we looked at how we could set resource reservations, limits, and shares on virtual machines. An alternative to doing that on individual virtual machines is to do that on groups of virtual machines using resource pools. So I've set up an example here with some resource pools configured on a standalone host. I've actually created a DRS cluster with no nodes in it at all, but I've been able to create some resource pools in it. If we take a look at the properties of a resource pool, we'll see that it's all actually quite straightforward. If I just edit the settings, we'll see that it looks a lot like the options that we have for reservations and limits on a virtual machine. We have CPU and we have memory. We can use reservations, we can use limits, and we can also use shares. Because this is going to be applied to a group of virtual machines, we're going to want to consider that the reservations and limits here will have to be pretty high. Now, if we've also set reservations and limits on the virtual machines, anything that we reserve for the virtual machines has to be available within the resource pool. So if I have a limit on the resource pool that's lower than the reservations on the virtual machines in that resource pool, it's not going to work and it's not going to allow us to bring those virtual machines up. Now, depending on whether we're running standalone or whether we're part of a DRS cluster, we may have the option to nest our resource pools together. So if we take a look, actually, let me close this dialog for a second. At the cluster level, I cannot create resource pools inside resource pools, but I can create resource pools in the cluster. On a standalone host, in this case, this host is still outside of the cluster, you can see that I've created resource pools, which also have resource pools, which could then also have resource pools, and we can continue down for several layers and create a very complex hierarchy. The difficulty is that it can be difficult to predict, or it may be somewhat counterintuitive as to how some of these things will behave if we actually do it that way. So if we take a look at my host example here with two root resource pools effectively, I've got one called Demo C and one called Demo F. And then I actually have a virtual machine that's not turned on right now, the virtual machine that I'm using for the vSphere data protection videos. If I go into the properties of this virtual machine, we can see that it has the default options. It has normal shares, there's no reservations, there's no limit. Same thing for memory and disk and some CPU settings that we don't have in the resource pool anyway. And if we look at the resource pools themselves, they're set up pretty similarly, right? Just normal shares and no reservations, no limits. And our other resource pools set up the same way. Considering all that, how should we expect this to behave? Well, if there's no competition for resources, then everyone will be able to get access to the resources they want, subject to the limitations that we've either placed hard limits on those virtual machines or on the resource pools, or the declared settings for, how many CPUs they have or how much memory they have and so on. But when competition starts to occur and we don't have enough memory to provide everybody with what they want or enough CPU cores to provide everybody with what they want, then we're going to have to start doing things like swapping and descheduling those virtual machines based on priorities and so on. So the only real way to achieve priority, other than having all of our virtual machines in a flat structure and then assigning shares to them directly, is to start organizing them into pools. So in this case, at the root level, I've got two resource pools in a virtual machine. What we're actually going to see is that this virtual machine is going to get tons of resources because we're actually treating this as an equivalent peer to the virtual machine resource pools as well. So effectively, this virtual machine will get 33% of the resources of that host. Everything running in this pool is going to get 33% of the resources, and everything running in this pool is going to get 33% of the resources. Now, I could tweak that. I can make one high, I can make one low, I can make one normal. But it's all done at the peer level. So if we have virtual machines at the same level in the hierarchy as other resource pools, those virtual machines are going to be treated at the same level as the resource pools would be, and they're going to potentially get a lot more resources than we had intended. Now, if we're doing all kinds of reservations and things anyway, it might not be a problem because you've guaranteed that those resources will always be available, but we can't usually do that. If I open up Demo C, we'll see that we have the same case. I've got two resource pools and then a virtual machine as a peer. So again, out of the 33% of the resources that are going to be available to this resource pool, comparing the other resource pool that it's peered with and the other virtual machine it's peered with, then this virtual machine will get 33% of that 33%. Everything in this resource pool will get 33% of that 33%, and everything in this resource pool will get 33% of that 33%. And if we get down lower, then each of these virtual machines will get 50% of that 33% of that 33%. And so we can see that in this case, our vSphere data protection VM is going to have no problems whatsoever, but these poor virtual machines nested way down in the hierarchy might have more problems. In this case, effectively, W2K8R2-4 and W2K8R2-1 will have access to the same amount of resources because this virtual machine -1 is the only machine in that resource pool. But we could see that -3 and -6 will be much more affected here. Or when we go to -2 here, it's also going to have effectively quite a few resources because it's the only thing running in one of those root pools. So it's going to get basically 33%. It'll have effectively the same access to resources that this other virtual machine vSphere data protection does. Now, one thing that we can do is if we have started to set reservations inside the virtual machines, we have not done that on the resource pool, or we haven't set enough of a reservation on the resource pool, then you'll notice we also have an option that talks about expandable reservations, which will allow us to, if they haven't already been allocated anyway, borrow reservations available from the parent resource pools. Potentially, although Demo E might not have those resources available, maybe Demo E can obtain them from Demo C, so long as they haven't been reserved already by some virtual machine or the virtual machines and other resource pools below it. So all of that we have to be a little bit careful with. When we're doing this on a single host, I mean, unless that's a very, very large host, I'd be very surprised that we would really need to use this many resource pools. And when we do it in a DRS cluster, we can see that we can only create a flat hierarchy for resource pools. So I think that tells us that going in and doing deeply nested, super complicated resource pools is probably not going to give you a major payoff. But if you have large numbers of small virtual machines, then potentially we might be able to do that. I mean, if you have huge servers and small virtual machines and, big numbers, maybe we could do that. But when we start using resource pools across a cluster, then what we're actually doing is pooling all of the resources of the cluster, and then those resource pools are going to be serviced out of those. And this is going to help guide DRS to help make planning decisions and determine, which virtual machines should be getting priority access to resources. And of course, if there are reservations and limits set up, to help us plan the, most effective placement of virtual machines across all the different hosts in the cluster. With reservations, with limits, we can be very exact and specific about the numbers. And, if we've made a budget charge or a budget transfer for another department saying, we're going to give you exactly X gigabytes of memory and X megahertz of CPU, you could do that. But in general, if we're trying to do things more on a priority basis, then it'll be useful to just say, certain resource pools are high priority, others are normal, others are low, or maybe to start using some of the custom settings that are in there. But you're really going to want to think about, the numbers of machines that are there. When we start guaranteeing resources, especially if we're using HA and we're talking about admission control and reserving resources to make sure that we can always maintain those guarantees, anything that's a reservation is a hard guarantee that those resources will always be available. And if they're not available, those virtual machines won't start. So that can affect HA greatly. So take a look at the DRS video, take a look at the HA video, take a look at the virtual machine reservations and limits videos. And between all of that, VMware gives you some very good tools to influence performance, but we're going to need to use those tools effectively, and we're going to need to be very, very careful and really take the time to understand the workloads inside your virtual machines and maybe manage those too. We have tools like NICE in Linux that we can use to set priorities. We have tools like the Windows System Resource Manager that we can use to set priorities inside the virtual machines. So that can all be really useful.